right, stat students. So we are up from where the live lesson ended. So make sure that you've seen that on Play Pause It. That is posted. That was actually yesterday that I posted that. And we're going to talk about a few concepts, and we'll start looking at some examples in the problem set. So let's go ahead and get started here. All right, so this is the data that we got from class with the pennies, and we had one live watching distance learner that also submitted their data. So we made some observations about this, and what happened was everybody in class did 6 samples, 2 of which would be size 5. Let me move my camera over here. Another 2 would be size 15, and then another 2 would be size 30. And we made an observation that you notice how as we go from larger sample sizes, the distribution gets less and less spread out. Okay, so that's something that's very important for this chapter, and we'll talk about that in a few definitions. Then during class, I also drew these little lines here. Okay, the blue lines represent the means of these sampling distributions that we have, and then the red line represents what we're trying to estimate. Okay, because we're trying to answer the question, what is the average age of a penny in the United States? That's what we wanted to know. So everybody took their samples, and everybody's individual sample is their estimate, right? That's what that's supposed to be. And when we gather all of them together, we get a more accurate estimate when we sort of take the average of the samples. All right, so for instance, these 2 points down here, they are very bad estimates probably because they're so high up. All of these points up here and up here, those are very bad estimates. But you'll notice as we increase that sample size, on average, the points did a better job of estimating the value that we're trying to predict, the red line, which is the true mean value. Okay, so we are going to write down a couple definitions. So below, if you didn't watch the lesson already, you need to make sure that you have this copied in your notes. You want to have these dot plots in there, so get that on your notes. And we're going to go ahead and define 2 or 3 terms. So I'll definitely pause the video for you to do that. But we're going to start with these 3 terms here. Okay, so you have a parameter is a number that describes some characteristic of the population, and then a statistic is a number that describes some characteristic of the sample. Okay, and then here's what the whole chapter is about down here: the sampling distribution of a statistic. So it is the distribution of values taken by the statistic in all possible samples, and we need to underline this, of the same size, that's important, from the same population. Okay, so I'm going to pause and let you write this. Okay, so it's going to be super important that we understand what a parameter is. So let's go ahead and add the symbols that we'll be looking for with this. We have, it's going to describe a population, so we have population mean. We're going to use mu to describe that, so add this to your definition. Or we're going to be using population proportion, which will be the next example that we'll be getting to. Now we could do all kinds of statistics. We could figure out any number we wanted. If we wanted to find the median of a population, we could do that. But what we're mostly going to be focused on is going to be mean, which is mu, and then proportion, which is going to be p. Okay, population proportion p, which we can also think about as probability. Okay, that's another way to think about it. So what is the population proportion of dice rolls with 1 die? So if I have 1 die here, what's the probability? What's the population proportion of getting a 2? Well, it's 1/6, right? So we'll discover that a little bit more later on down the road. Okay. Next, we're going to have the same thing for for this, except we're dealing with a sample. Okay, so we just change the word to sample instead of population, because that's what a statistic describes. So let's get the symbols in here for those. So we have the symbols for sample mean, which we already know as X bar, and then we have the sample proportion, which is going to be called p hat. Now we're going to talk about p hat more in the next activity that we do. This one will be one that we're doing through a simulation online. But these are very important symbols, okay? Very, very important symbols. So we're going to go back to this right here, all right? And we're going to define for our context the parameter of the situation. So the parameter, remember a parameter is a value that describes some characteristic of the population. So what is the population? Let's actually also write that down. That's going to be important. So we're going to put here population. So what was the population in this setting with the coin flips? Well, or not coin flips, coin sampling. We're interested in finding the average age of all US pennies. Okay. So the parameter is the value that we want that describes this population. What did we want to know about it? Well, we wanted to know the mean age of all US pennies. That's what we wanted to know. And so mean age for a parameter, what symbol are we going to use for this? Well, which one do we have? Well, it's going to be this one here. Mu, okay? That's what we found. So there's how we find our parameter. This value, it's really the question we're trying to answer when you have a setting. If you wanted to know any question that's sort of large scale, what proportion of, or what is the average height of United States males? Well, you have all United States males in that case, and then you're trying to find the average, the mu of that. So in order for us to answer this question, we had to create a statistic, right? Which is values that describe a characteristic of a sample, okay? So what did we do with our sample? So everybody in class took these different sample sizes, size 5, size 15, size 30, and we calculated a value that represented that sample. So we also need to know what was the sample? Describe what the sample was. That was 5, 15, 30 pennies. Okay? And it would be the mean age of the samples of 5, 15, or 30 pennies. So that would be our, hold on. Our sample is the samples of 15, 13. So that's our actual sample. Now, the statistic would be the mean age of, and we'll rewrite this. Okay. So this is our statistic. Now, what's the symbol that goes for this? Well, it is this X bar. So we'll put that over here. That goes right here. All right, so that's going to be sort of the first step here of looking at these scenarios. A question's going to be asked, and it's going to be asked about a large population, right? That's how this goes. And we're interested in a parameter about that large population. Now, we can't really answer that question. For instance, there's no way for us to know what the true mean ages of all U.S. pennies. There's too many pennies. They're in dark places in the United States that nobody wants to go and find them all. So, we have to take samples and calculate these statistics to get a good estimate. So we'll bring that back up. We did this with these little lines, so we'll talk about that in a second. But let's practice this idea of parameter, right? Here is the problem set This is going to be due in a few weeks, actually. But I've put all of this, well, not all of it. I got the first 17 questions on Delta Math. So if you go to your assignments in Delta Math, you will find Chapter 7 problem set. And I've put the first 17 questions in here. So you'll notice that if we go to question 1 here, okay, you have the exact same question. I'll move my camera. The exact same question as what we have here. A survey conducted by Black Flag asked whether or not a certain type of roach disc was effective in killing roaches. Okay, so it's the same exact thing. It said 79% of the respondents agreed that the roach disc was effective. It says the number 79% is a what? Okay, so what we want to know, or what we want to do, is we're going to list out, just like we did on this slide here. We want to know all of these parts. Okay, that's what we want to know. So we're going to do that on our on the Delta Math, and we're going to talk through the situation.